let's do the first problem on the linear equations assignment. So here's the worksheet. And it says, for each of the following data sets, draw a graph where the first column is the horizontal axis and the second column is the vertical axis. Determine the equation that describes the line, include units in your slope and vertical intercept, and write a sentence that describes what the graph and equation mean. Okay, so let's do that for number one. So here's the data, and let me zoom in on the data for problem number one. Oh, that's how I see without my glasses right there. Okay. And there it comes in. Okay, so here's volume and mass, and here are the numbers. So the first thing I want to do for part A is graph it. This off the side. And zoom back out. Oh, for crying out loud. So I want to graph it, and volume is my horizontal axis, and mass is my vertical axis. And so the volume goes from 0 to 15. So we'll put 0, and then I got to increment this, so I'll just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 50. Look at that. That's what you call 28 years of experience right there. All right, so 5, 10, 15. So notice you don't have to put a number next to each increment. You know, you can go 2, 4, 6, 8. I don't care. Just make it easy on yourself. And then it's volume in milliliters. Okay, so there we go. And then the mass in grams was from 0 to 60, so I'll just go 10, 20, 30, 40, 50, 60. And then I'm going to label it mass in grams. So I'm going to use M for mass and V for volume. Okay? So this is what I'm looking for when I'm looking at a graph. Is it incremented properly? Is it labeled with both the quantity and the unit of measure for that quantity? So it's got to be labeled with the units, incremented properly. Okay? You have to have that on every graph you draw. Then we just have to do the points. So 0, 0, 3, and 12. So 1, 2, 3, and then 12 would be right about there. Here's 12, something like that. And then 6 and 24. So 6, see 24 would be right about there. Oops, 24. Now this is a hand sketch, so it's going to be a little rough. And then we have 9 and 36. So here's 9. And notice I kind of go up, and 36, go over. And then finally we have 15 and 60. And notice that makes a nice straight line. Okay. Now maybe it's not perfectly straight. I'm not using graph paper. Maybe I should get some graph paper for this, but I don't know. I just did that. So it should look something like that. So there, and that is part A, right? It says draw a graph. First column is horizontal, second column is vertical. Okay, now B. So this is part A, and then B. What are we going to do? We're going to determine the equation that describes the line. So I like to, especially at the beginning, I like to do this. Y equals mx plus b. So that's our crutch equation. That's where I always start. Okay, I'm going to write a linear equation here. So, but instead of the y-axis, what is this? It's the m-axis. Now don't put G. What does G stand for here? Grams. Those are the units. Okay, units will be put with the numbers that I plug in, but we don't use the unit as the variable name. What is this? Mass. There's lots of ways of measuring mass. You can use grams, milligrams, kilograms. You can even use pounds, pounds mass and stuff like that. This is what we're measuring, and this is how we're measuring it. Okay. Now we're going to need to figure out the slope. Well, what's the slope of this line? Pick 2 points on the line. Make a little slope triangle. Well, this was 3, and this was 9, right? So what's the run? It's the rise over the run. So the run here is from 3 to 9 is what? 6. And 6 what? Milliliters. You always have to tell me what that number is representing. And then here's the run. Well, we started at, what was that, 12? And this was 36. So what's 36 minus 12? 24. So that's 24 what? Grams. And this is this is a very easy problem because it's all nice and 24 divided by 6 is what? 4. For what, though? Grams per milliliter. Okay. And then, you know what? I didn't do a very good job with this. I should have put this above it. But anyway, so this is really the slope. So the y is m equals the slope, which is this little m here represents slope. For this m represents mass. This m represents slope, so it depends on what you're looking at. Grams per milliliter. Now, what is the x-axis? V. For volume. And then plus, now what is, and I use B again, I should use y naught. What is y naught? 0. So you can rewrite this, the mass is equal to 4 grams per milliliter times the volume. Okay, and so that's part B. Include units in your slope and vertical intercept. Well, we don't have a vertical intercept, it's 0, but we do have a slope, and we included the units, and we included the variable names, so that is our mathematical model that describes how the mass is varying with volume. And then part C, it says, and this is kind of the hardest thing to get precise, write a sentence that describes what the graph and equation mean. And I would say, for every milliliter of volume, you get 4 grams of mass. Okay? Isn't that what's going on here? You add a milliliter of volume of this stuff, you're going to get 4 grams of mass. What is this right here? Anyway, you recognize this number from chemistry? How many grams per milliliter? That's density, yeah. So if you were to look at a mass versus volume graph, the slope of that graph, also called the derivative, if you're in calculus, is density. So that's how you do number 1. Any questions? Yes? Does it matter what 2 points you choose? If it's a straight line, it does not matter what 2 points you choose. You could have used this and this. Let's see. Let's go from 0 to this one, 0 to 6. So that's a run of 6. If I go from up here, what is this? This is 24. So 24 divided by 6, oh, it's 4 again. Pick any 2 points. Now, that's a really good question, though. Like, what 2 points do you use to calculate the slope? These were perfect data. All the data points were right on the line. But sometimes you'll get data that looks like this. Because measurements, so here's your y, here's your x, whatever they happen to represent. But you'll get data that's a little bit scattered, like this, right? So what you do is you draw your best fit line through it. Now, there is a way of figuring out your best fit line, with mathematical precision, but in this class, we're just going to kind of eyeball it. Something like this. Does that make sense? Right? Some of the data points are below the line, some of them are above the line, so we just kind of average it out. Why does data look like this, by the way? Because measurements are never perfect. There is a level of uncertainty, there is a level of error in almost every measurement. And so sometimes they're going to be a little off. Does that mean there's no pattern? Does that mean we can't extract any meaning out of that data? No. It means the world isn't perfect and we have to deal with it. It's okay. So now notice that none of these data points fall on the line, do they? So how am I going to figure out the slope? I mean, if I did this, I would get a slope that's too steep. If I use these 2 points, I would get a slope that's too shallow. This is too steep. This is too shallow. So what do? I don't use any of the data points to figure out the slope of that line. I'll pick 2 points. Well, I could pick 0 because that's easy. That are actually on the line that I drew. So you do not have to use data points. You can use 2 points that are on the line to figure out your slope. Does that make sense? Okay, so I'd just arbitrarily, I'll pick that point, and I'll say, okay, here's my run, here's my rise. So take this difference here and this difference here, divide them, and I've got my slope. So you do not have to use. Now, I always use data points if I've got data points that are actually on my best fit line that I drew. Why? Because it's easy. I don't have to read off the graph. But if none of my data points were laying on the line, that's okay. I just have to say, okay, here, well, that's x is that, and y is that. I just read it off the graph. Excellent question. Any more questions? That is all.